Good afternoon. Welcome to the Business Special Interest Group's live presentation. We have our guest today, Jim Rogers. Jim is a managing director at AMG Results, a collection of senior experts in the process management, systems dynamics, design and implementation of management systems. Jim specializes in facilitative consulting, assisting decision makers and leaders understanding the issues before them and designing effective actions to deal with them. Jim has been consulting with the Mayo Clinic in Rochester, Minnesota since 1997. He led various groups and teams through model-based business transformations. Jim and his team were recent recipients of the 2015 Systems Dynamics Society Application Award for their work titled Biomedical System Dynamics to Improve Anemia Control with Darbepoetin Alfa in long-term hemodialysis patients. Today we're discussing dynamic healthcare models and accelerating the diffusion and adoption of those models. So with that, I'm going to hand it over to Jim, and welcome, Jim.
Well, thank you, Seth, and thank you, Rafat, for setting up this opportunity to speak with you and share some of the work that we have done and what we're looking at in the future. I've prepared some thoughts to review with you. I don't feel like I'm imparting great pearls of wisdom to you. I feel rather that I'm trying to start a dialogue. As I'll explain throughout the presentation, a few weeks ago, maybe 8 weeks ago, I gave myself the task of addressing the question, why don't innovations in healthcare diffuse more rapidly than they do? And during that time period, I've expanded my issues list, if you will, from 1 or 2, I was sure these are the culprits, to about 15 areas. And what I'd like to do is briefly review those with you, and for the purpose of setting up some feedback from you as to whether or not those are correct, if they're too ancient, if they're current, what am I missing, what needs to be revised, what needs to be restated, and so on. So that's the intent of the presentation today. So with any luck here, I'll be able to turn on my screen and show. I am screen sharing? No, I'm not. I'll do this, and I'll bring up some slides I prepared for you to look at.
Well, while Jim is getting ready here, I do want to call your attention that we have an active Q&A forum. If you join the link for the Google Hangout on the Google Plus page, there is a button that will allow you to ask questions that we'll answer live on the air here. So we encourage you to do that. And back over to you, Jim.
I appreciate that. Let's work the Q&A that way. Some questions we can answer on the fly. We'll make a judgment there. And some questions we'll reserve and follow up later in responses to those. But if at any time, if I'm going too slowly or too quickly, please use the Q&A feature to let us know how to adjust to better meet what it is you're interested in seeing. Okay, so I've already mentioned some of the caveats here. What I'm really sharing with you is what I call a scrapbook of clippings I've put together from various articles and papers and things I've looked at. This presentation will probably develop over time, be more polished, and be more, I don't know, have more gizmos in it, but right now it's a working document for us to talk about. Right. It's just a survey. Yes?
Would you mind sharing out your screen so we can see the presentation?
I'm really sorry. I thought I had.
That's all right. Not a problem at all.
All right. I forgot the missing final little button there.
There you go.
Okay, so I was going through some of these caveats. You can see those, right?
Yep, that looks excellent to me.
Okay, thanks, Seth. All right, so this is a scrapbook of clippings that I've put together. It's a guide for a conversation that I want to have with you and with members of the Biophysical System Dynamics Special Interest Group. What's really neat about this webinar is that Rafat and Seth reached out to us in the Biophysical System Dynamics Special Interest Group to see what kind of commonalities there are, and I think they're huge. There are things we can talk about here. Feedback and so on. I own the mistakes, I own the omissions, I own the naiveties, and I'm certainly welcome to revise and correct those as we learn more. Okay. the background is Seth has already alluded to it. I had the privilege of working with Mayo Clinic for about 10 years in their nephrology department. Nephrologists are kidney doctors. And the initial assignment was to look at a reporting system for how their hemodialysis patients were doing. And as we developed the reporting system, we became intimately familiar with the underlying data, which allowed us to look at individualized longitudinal data for a particular measurement of importance, hemoglobin, in individual patients. And what we observed over a period of time was an oscillation in their hemoglobins. And being system dynamics as dynamicists as we are, we knew that there was a system that generated that behavior, didn't we? So by asking the right questions of not just nephrologists, but also hematologists, blood doctors, we're able to identify the structures that generated the oscillation and dampen the oscillation, which proved to be extremely beneficial to patients and to Mayo Clinic in terms of cost reduction and efficiency. It was just kind of amazing. It was one of the most exciting projects I ever worked on. So all I did on this slide was, can you guys see my cursor moving around? Seth?
Yeah, your cursor is coming through.
Okay, good. So I can point at things with my cursor. All right, this is just a little clip of Dr. James McCarthy, who voluntarily, just on his own, put out a 9-minute video that says this is worth $2 billion to the care industry for hemodialysis patients. Very excited about biophysical system dynamics. This is the Mayo Clinic Proceedings article title. Here's a little snippet of the core of the model we built, and you're not intended to read that or study that right now. It just highlights it. Here we've got 4 of 6 parameters highlighted. There's a physician assistant associated with it and running the model. There are a couple compartments to the model, but it gave a real operational insight into how the process of creating red blood cells within inside the skin and marrow works, and there you could manage it. So here's some results, and this chart down here is saying, you know, over January of 07 to December of 10, there was the cost per patient was cut in half almost, or, you know, not quite in half. We had like 650 patients. Then after 2010, we turned this into a monitoring business where we worked with the patients with up to 1,000 patients for about 5 years. And now that system is being commercialized. We've switched over to that system inside Mayo Clinic. It's a more robust software application, and they continue to use it today to great benefit. So that's the background. And during those 5 years, I was wondering, you know, why isn't this diffusing more rapidly through the industry? Because it's amazingly effective, and that's what motivated the study. So I go to the next slide. Here's a citation for the paper, and if you want to, there's a couple links to clueless videos I did 5 years ago that are an explanation of the presentation of the project. This talk is not about that. This talk is moving on from that. Okay, so I want to, you know, say that was great, but the question came up is, why don't these things diffuse more rapidly? And you can look at this material if you want to get more information on the original project. Okay, so what I noticed, now again, here's some snippets. I'm not asking you to read this. I just want you to look at this as an artifact of the dialogue that's going on in healthcare management. So here's this title up here, many words in the title, and what it says is some people looked at the data for 35,000 patients and discovered that the use of intravenous iron is causing problems, maybe increasing mortality, maybe increasing hospitalizations, may not be good and effective for the patients. And as it turns out, intravenous iron is associated with the drug that the first project was about. I won't even get into its name and so on, but they're connected. And the conversation is, hey, we don't understand the dynamics of how this is working. And I highlighted the bottom statement there. In light of these associations about problems, we need a well-powered, now read there, we need a highly statistically significant test, a clinical trial to evaluate the safety of different IV iron dosing strategies in hemodialysis patients. This is urgently needed, okay? So I get excited about this. I say, all right, what I want to do is create a bench, a system dynamics biophysical bench to do the clinical trial instead of doing, or maybe alongside doing a standard, let's say, I'm going to use, well, I'll introduce a word later, a statistical analysis of which treatments seem to be effective and which seem to be not so effective or dangerous even. So the difference would be we'll get at a causal explanation. The clinical trial might get at a correlational definition. All right, so that's in the literature. But in addition to that, in 2011, we formed, Ed Gallagher and I formed the Biophysical System Dynamics Special Interest Group and had a formative meeting in 2011. And we asked folks to identify areas in which system dynamics could be used for inside the skin modeling. Now, these are the 20 or so topics that they came up with during that meeting. Those are the headers. Within each topic, there were 3 to 4 areas of study that folks said, you know, we would like to be looking at these kinds of areas. So within an hour's time, practitioners of system dynamics with a good mix of healthcare folks were able to identify about 80 areas that we need to look at. That tells me, you know, this is a field that needs to develop. This needs to grow, and we need to do these kinds of things. So as I'm preparing for the meeting in the Netherlands this summer of the Biophysical Special Interest Group, I'd like to put the question in front of them, well, hang on a second. Suppose in any one of these areas we had the model that explains it all. It gives the operational insight. We know how things work. What are we going to do with it? How are we going to get that implemented, and how are we going to put it into use? In other words, what are the barriers to diffusion? Why isn't this working? Okay, that's why I put this question myself, and that's why I'm talking to you today. I'm going to share with you where that early thinking is. Okay, so there's a need, but we need to figure out how to facilitate its growth and development. So in order to have all of this stuff, and Seth, I need you to help me stay focused on time. Okay, if I'm
all right, okay. I can do that. We do have one question that I think is pertinent at this moment.
Go.
We're wondering, what do you mean by inside the skin models? Can you talk a bit more about that?
Yeah, the anemia management model for hemodialysis was really about the body's attempt to maintain homeostasis. That is a balancing loop. That is, the body at all points in time needs a correct level of red blood cells to function properly. If the body does not have the proper number of red blood cells, actions are taken in the body that stimulate responses to that cause the body to create more blood cells and close the gap. All of that is happening within the skin of an individual. It's a dynamic system inside the individual. And within any individual, you and me, there are hundreds, if not thousands, of dynamic systems that are controlling the way our body works. System dynamics enables us to gain amazing insight into how those systems work. We were differentiating inside the skin models from outside the skin, more like policy models, like how do we propagate this among the user groups? What about the regulations in the system? What about the payers and the whole healthcare system dynamics, the workforce supply, all of those things? Mm-hmm. So that's what I mean by inside the skin models.
Very good. Thank you.
All right, good. So Seth, keep me honest on time, and if I'm going windy, just throw something at me.
No, we'll do.
Okay, good. Now, in order to have these things make sense, I want to ask you to go to the future with me. And I want you to imagine a future reality in which each of the applications on the previous page and the extension to the anemia management model that we showed in the article before and the anemia management model itself are up and running, it's addressed, and we've got individualized, patient-by-patient dynamic models. We had one model with 6 parameters in it that we fit to 1,000 patients. Never changed the model, used the same model over and over again. Imagine that's all in place. Imagine healthcare workers go beyond merely treating the symptoms, and they understand and interact with the hundreds and thousands of systems I described a moment ago with inside an individual patient. If Craig, the physician assistant, were here to tell you about his experience in the hemodialysis project, he will say that by stabilizing the hemoglobin of the patient, he gained a window into the patient's overall well-being, and it was just an amazing insight into it. And so he had a much better understanding of his patient. So healthcare workers go beyond. Medical education delivers great results, what I'll call operational clinical insight, as opposed to statistical probabilities about what might happen, right? The real thing for residents, medical students, healthcare workers, and the field overall. It just aims at creating health rather than treating disease. Now, these are not my thoughts. This is what the field is talking about. There's no new news here. This is what they want to do. But think about it. This morning, as we're speaking, or this afternoon, or wherever you are, there are thousands of medical students studying anatomy and physiology, endocrine systems, circulatory systems, skeletal systems, and there's not a lot of systemically oriented stuff out there. The world I want you to imagine right now is there is stuff out there, and they're able to look at these models and understand how the body actually works and responds. Or in the area of research, it addresses individualized and population health level dynamics, takes these clinical insights from systems thinking, system dynamics, STSD, to ongoing clinical research projects. In other words, there are research benches that use system dynamics. Now, I coyly kind of put healthcare workers, that's practice. Medical education is medical education, and then research. Typically, when folks are talking about healthcare, they're talking about practice, education, and research. And I'm suggesting to you there's 3 different future markets I want you to be thinking about. We could put in a couple others, administration and policy, but practice, education, and research are good for now. So this is a future in which highly effective applications, biophysical, system dynamics applications, are in widespread use in all of healthcare. Imagine that world is in place, and we're there now. Now look back to 2016 and say, what is it in this current reality that we can use to bridge the path to the future? That's why these things will make sense. Any questions? We're doing okay? All right, good.
Yeah, no questions here.
All right, now I took a look at Jack Homer's work. Jack is, and I haven't cited him properly through this, but 1980s, he's doing a thesis on the diffusion of innovations in healthcare. And he's written extensively on these 2 curves, which you're all familiar with. Why do some applications follow the successful curve, and why do others grow and collapse? What's the difference? So the question I'm asking is, what are the current realities in healthcare research, education, and practice upon which we can build bridges to the desired future reality? And if you're interested in that process of that kind of thinking, I encourage you to take a look at anything Robert Fritz wrote on the creative process. Just look him up. You'll find dozens of books out there on the creative process. He's got quite a practical view on how you create futures, and that's where I'm coming from with this question. All right, so that leads to this. Here are some areas I briefly want to go through, and Seth, I really need you to keep me honest here so we don't get bogged down. I just want to fly through these things and describe them to you so that they're the basis for feedback. And I also want to be asking you to think about, as we walk through these topics that are all impinging upon the diffusion of innovations, if you can, be thinking about, is there a stock, like a stock or 2 stocks that are relevant to this area, that is a resource or a barrier or something to be increased or something to be drained? Maybe that'll make more sense as we go along, but I'd like you to be thinking about how do we begin to flesh out what each particular area is about in order to get at what do we do to speed up the diffusion of innovation in healthcare. All right, so pardon me for putting them in a circle. I wonder why I did that. I think the reason I did that is because I don't want to have a bulleted list implying that these things are independent of each other. They're not. They're overlapping. There's feedback. Everything's related to everything else. You know the story, all of that. And they are in kind of a precedence order as I developed and refined and remeshed this list. If we address the first one, the science of healthcare must address the science of healthcare delivery, then we can go all the way around the circle to number 15, and that should help us, along with all the others, advance the evolving science of healthcare delivery. All right, so there's kind of a rough order to those things, and I briefly want to go through those. Any questions?
So we do have a question about the previous slide. I'll leave it to you when you want to take it, either now or later. I believe it's Kim Warren from Strategy Dynamics has asked, the right-hand curve looks wrong. It implies near half adoption and then collapses. More likely failure equals never getting to more than a few % of progress. Is that what you're trying to present here?
What I'm trying to present here is sometimes a good idea gains a little bit of a foothold, and then it's not practical, it's not implementable, it doesn't widely diffuse, and there's just no value in its further development. That's what I'm trying to communicate there, Kim.
Okay, very good, thank you. Carry on.
All right, so just want to go through, I've already alluded to this one. I think I would rewrite this one. The science of healthcare is in the process of informing the science of healthcare delivery. And the reason that's important today is because the buzzword in medical education is all about systems of science, healthcare, and the cross-collaboration and the teams and the use of gizmo technologies and all sorts of things. And there seems to be an absence of the science of healthcare that could be based upon system dynamics. And if you'll permit me to use my data point of one, once again, the hemodialysis, it was very frequent when I spoke with the nephrology doctors at Mayo Clinic, the #1 nephrology department in the country for over 10 years, and spoke with hematologists to hear a remark from them that stated, no one has ever asked me that question before. And what we were doing was asking them simple, straightforward system dynamics questions. For example, we need red blood cells to be at a certain level. What causes them to increase and what causes them to decrease? Oh, well, it comes from this, okay? That went on in droves. That happened throughout the whole project over and over again. And it led to a science of healthcare that was based on dynamic realities and operational insight. If that were to inform this buzzword of science of healthcare delivery, I think we would make greater progress. Okay, I'm going to move a little bit more quickly now because we have many of these to do, and I don't want people banging their foreheads on their desk. All right, Jim Utterback, MIT, has been writing for years about the interplay of product innovation and process innovation. And he's said in many instances, you'll see a pattern of initial high levels of product innovation where a marketplace tries to figure out what a product is going to become, at which point it reaches a dominant design. In other words, an automobile is a thing with headlights and an enclosed body and an engine in it with an automatic transmission and 4 wheels. Okay, it took a while to define that dominant design. Once the dominant design is done, the degree of product innovation begins to decline, and then process innovation to more effectively and efficiently generate those dominant designs increases. After a peak in process innovation, it also declines. So in a final state, you have low process innovation and low product innovation. So those 3 states Utterback writes about are fluid, transitional, and what he'll call specific or fixed. And the characteristics of competition in those regimes or domains are different. And I'm wondering if in the area of influencing healthcare education, practice, and research, if we are in a predominant design period where the product that will emerge and the services that will emerge are not quite clear yet. That's got significant implications for competition. Related to Utterback's work is a piece of work. It's ancient, and I've got references for these things that I will distribute. It's ancient, but in addition to product and process rates of innovation, you've got the rate of market development. And what Abernethy and Clark, this in itself could be a whole hour discussion, but what Abernethy and Clark are saying is that you could have a situation where you have an emergent, undefined, nebulous, one-on-one type of market situation with a disruptive technology, okay, that can advance through product and process innovation down to a well-defined market that is self-reinforcing up to its saturation point with well-defined technologies that are no longer disruptive, pardon me, but are reinforcing. Okay, and there's a transition, there are pathways through that space. And I'm suggesting that the disruptive nature of system dynamics as applied to biophysical dynamics is not hard to understand at all, and it's one that we're all very, very familiar with. It's just our worldview. And that worldview is that structure causes behavior. And the event-oriented world is not thinking that way. I believe, and I want to be corrected on this if I'm way off, if I'm out there, but I just don't think people think that way, and I think it's our job to help them when they're looking at a set of data points to not look for the special causes or not look for the correlations, but to ask the question, what's causing that? Why is that pattern what the pattern is, not the individual data points? So that could be a barrier to further diffusion. Porter writes a lot about wrong incentives and wrong measures, wrong outcomes, and these aren't my words, these are his words. Wrong level of competition, wrong objectives, wrong forms of geographic markets, and so on. And then he says, here's the right things. And the basic idea is that what we need to do is treat not episodes of care, but cycles of care throughout the whole process, through the patient's whole time. So we start to need to look at longitudinal data and patterns of longitudinal data. And there are many, many other things there, but there are some misaligned incentives that is a current reality that is blocking the diffusion of innovation in these areas. Okay, I'm moving on. Champion communities. We all know about the importance of having a voice with authority and the ability to move resources and make things happen. It's underdeveloped. Let's find them in practice, medical education, and medical research. But it's not just the champion that we're looking for, it's a team, an innovative team. You need, in addition to a champion and a sponsor, you need a gatekeeper, an information gatekeeper, who's scanning the external environment for types of information that can be added to the respective domains, again, of education, research, and practice. You need intrapreneurs within organizations to lobby for the types of innovations and change in processes that are needed. You need project managers who are aware of what it's going to take to practically implement, design, and implement some of the interventions we're talking about here. So you need a team of people, and if we're going to speed up the diffusion of these innovations, we'll need to create those communities as a resource to help us happen. Short-sighted, well, this one I need to do a lot of work on, but we're looking at the industry of treating symptoms, the industry of working with care providers who are trained, and this is a quote, this isn't me, this is a nephrologist telling me what medical education is like. Doctors are not trained to understand, they are trained to prescribe. Okay, they have to look, and because of the incentives and because of the pressures, we're not going to understand the patient, we're going to prescribe for the situation, or we're going to move on. And pharmaceutical works into that system, that structure like that, and there are things that we can do. this can affect continuing medical education as well. This can affect the way clinical trials are done, and I'll say a little bit more about that. But that's a potential barrier to the diffusion of these innovations. This was really helpful to me. There's another ancient paper by David Teese from Stanford. This paper was written in the 80s. It was entitled Profiting from Innovation. And David is writing today, and he's revised that paper in '86 was cited by about 10,000 folks, and he wrote a reflective paper on it 20 years later in 2006. But in viewing some follow-up videos and doing some more background study on what David Teese is all about, he made a distinction that many of you are aware of and the world is aware of, but it was news to me and very helpful to me. And you say, look, an invention is not an innovation. Oh, he said an invention is something with utility that is created. And I believe the utility we create with our work is operational insight. That is huge utility, to understand how things actually work, so that you can do something about it, so that you can act. Well, David Teese goes on to say an innovation is invention plus what he calls the complementary assets that are needed to make the invention useful, applicable. For example, in our data point of 1, in addition to the model, we need to develop data acquisition systems, data reporting systems, interfaces to the order entry systems, feedback systems, monitoring systems, and put it all in a package where the model could do its thing and render useful information to decision makers, so again, they could do something about it. So we will need to work on what we need to add to our models to make them applicable in the fields we choose to deliver value. David Anderson, and I forgive me for not recalling the name of the co-author of the Innovation Butterfly. He's looking at the interplay of the market and the market expectations, the portfolio of product and its capabilities, the gaps between the product portfolio capabilities and the, I shouldn't be using the word capabilities, product portfolio characteristics and the market expectations, and then the innovator's organizational capabilities to close the gap quickly. And he gives some really exciting examples through that reference. Again, I have a citation for you that I'll give you. But he's talking about distributed innovation, which biophysical system dynamics could clearly be distributed across organizational boundaries, that is, making it kind of complex. And I think we can understand the nature of the market, its evolution, using some of the previously discussed topics, and figure out maps and pathways to navigate through that space and manage the process of distributed innovation. Sanity check. We have questions compiling, or are we doing okay?
No questions thus far. No additional questions, I should say. We're doing good on time.
Okay.
5 minutes left in the hour.
All right, I shall continue. This I need to do some work on, but so it takes money to go off and develop a biophysical system dynamics bench for practice, or one that can be used for educational purposes, or ones that can be used for clinical trial. And in order to get the money, you have to show the benefit. The problem is the benefit that they're measuring by cost-benefit analysis don't always include the benefits to the ultimate patients. Even back in Teese's paper entitled Profiting from Innovation, he was talking about profit to the innovator. He was not talking about the benefits to the patient of having stabilized hemoglobin, improved quality of life, and so on. So we need to do something about articulating the benefits of investing in system dynamics or understanding biophysical systems within patients. I'm struggling with that one a little bit, as you can tell. And my current thinking is that what we're trying to do is quantify the benefit of just plain old insight into what's going on. And I really would like some follow-up conversation and talk about that and some clarification. I'm not quite sure how to think about that important topic. Now, this one, I'm going to use Frequentist. By that, let me open it up this way. A friend recently pointed out that the American Statistical Association put out a statement this quarter, 2016, saying, people, could we please stop misusing the p-value, the probability that our null hypothesis is mere chance or an actual fact. And I was told that it was a huge step for the American Statistical Association to put out a statement of guidance on the proper use of p-values. And in looking into it, the p-value world, the worldview is frequentist, right? That's what I read in the literature in my early stages here. How frequently do things occur by chance, and how frequently do they occur because they're caused, even though if we don't know what that cause is? Okay, the current paradigm in clinical research is frequentist. The golden standard is the p-value and the t-test to say we've got tiny little p-values, therefore our statistical model must be correct. Well, I'm really sensitized to that because in a data point of 1, once again, I saw an incorrect biophysical inference, learning it was incorrect from the benefit of using operational thinking, that was statistically significant with the data. And it was a reasonable inference about the biophysical dynamics. It was clinically plausible for these folks to make the assumption that they did. Unfortunately, it was operationally incorrect. And that makes a difference if we're going to understand what's really going on. So the current paradigm is frequentist, not operationalist. And I'm looking for a better word than operationalist. I don't think I have it nailed there. But it's a mentality. It's a worldview. Same thing. That is a barrier to the diffusion of what we do. Okay. Okay. Access to the right data. Yeah.
If I could break in just for a moment here.
Please.
We were getting some feedback from people that the Hangout has been stalling for people on the Google Plus page. So if you are experiencing that issue, I'd encourage you to visit the BSIG YouTube page where you can continue to watch the show live. Rafat will be capturing comments there if you want to leave them in YouTube comments, and we can continue the Q&A that way if you're having trouble. Anyway, back over to you.
Okay, we doing all right, Seth? Otherwise?
I think we're doing just fine.
Okay, very good. So when we think of access to the right data, in healthcare and individualized data, one of the first things that comes up in your mind is the confidentiality and the security of the data. And of course, that's very important, and that's a huge hurdle that needs to be covered. But beyond security and confidentiality, the data collected for the event-oriented world does not always match the data that we need to do reliable modeling. And then we get the additional hurdle of, well, why should we go to extra expense of collecting this additional data when we're meeting all of our reporting requirements? And that's a mindset thing you have to deal with. Specifically, forgive me my data point of 1, I hope it can be 2 soon. We needed additional measurements of patients' hemoglobins. An inexpensive test, but typically it was only done once a month, and we needed weekly measurements for a while to do that. Well, that needed to be a conversation. Why do we get at that? So now, in this future, to get to the future world, we have to define the nature of the data that we need, the frequency at which it needs to be collected, and so on in biophysical system dynamics in order to move innovations forward to justify that. And yeah, I'll stop right there. There's obviously lots there. Now, okay, and underdeveloped methodological procedures and practices. It occurred to me that we might be able to more rapidly diffuse the anemia project if it was embedded in a well-defined project plan. Specifically, we have these people that I mentioned on slide 2 that are concerned about IV iron, and they want to study its effects. Well, great. I want to build a model to study that too. And in order to have that approach make sense to researchers, I feel we have to embed the system dynamics research bench in a well-designed project plan that allows them to span the world for all these different sites, to do all the activities of a full-blown clinical trial based upon an interaction with a modeling dialogue, if you will. So as I looked into the field, what do I find? But over 1,000 providers of clinical trial management systems, CTMS, over 1,000. And what they're doing is they're saying, well, here's how you organize the data and your processes and your projects and your people and your resources to identify your research questions, gather and store the data, get access, do all of that, okay? Well, I will look for one of those providers who might have embraced system dynamics as the bench. It will surprise me if I find it, I think. But I hope I do find it, because I think that would be wonderful if we could have a plug-and-go type of research approach for people to use the kind of thinking and analysis that we do, which is different. Right? So that is a barrier. All right, this one, the social learning cycle, again, could be a whole conversation, but here's the top line. For CERN in Europe, CERN, they had the problem of the dissemination of knowledge that was gathered by the, I think the number was over 1,300 researchers from around the world working on the huge atom smasher there. And the question was, how do we propagate the knowledge gained throughout those various communities, and especially since the rate of change of the knowledge being gained is increasing because of the investments we've made in this amazing technology. And Boisot came up with an actual cycle of learning that occurs, where at the beginning of the game, you've got this random collection of facts and uncodified, concrete information that somehow needs to be codified and abstracted into something that's communicable. And once it's communicable, you're able to diffuse it to other groups. And when other groups are able to receive that codified, abstracted information, they're able to apply it to their own individual context, kind of break it down again, kind of remove the abstraction and make it and render it specific within their own contexts. Okay, and then to move from that to scanning the new environment of scattered information and begin the process all over again. We are in a social, that's what he called a social learning cycle, to go from there. And he's got a nice little three-dimensional map of that. I encourage you to take a look at Boisot's work. But we've got a knowledge management issue that we need to do that goes beyond the buzzwords. It needs to be real, where we're saying, look, here is operational insight and how a patient actually works with respect to the condition X. Okay, now we need to educate that, we need to research that, we need to revise clinical guidelines to adopt that and that sort of thing. How do we manage all that? How are we going to create the knowledge management and transfer systems that this will create? Whoops, I went the wrong way. And good old BAST. This is one of my first ones that everybody, correct me if I'm wrong, you probably all have talked about the BAST diffusion model. I was so naive at the beginning. I thought that when the nephrologist saw the tremendous results that were happening to the patient, they couldn't help but convinced their peers to take this on and try this on. Well, I was wrong. That's really not how it works at all. That kind of word of mouth does not occur. What happened was the nursing staff that supported the nephrologist with the hands-on experience with the patient were able to share the impact of using or not using this computer model, as they called it, for prescribing for the patients, and they would convince the doc. So it was their word of mouth, actually. But there was an additional wrinkle, because as I mentioned before, the problem showed up in a practice of nephrology, kidney doctors. But the problem was really a hematology problem. And I find it's the exception where a physician in one area is willing to make authoritative statements or, well, let's say binding recommendations, if that's even English, on a topic that's outside their own domain. And that is a huge barrier. And that's what the science of healthcare delivery is all about. How do we get at this cross-collaboration and cross-fertilization of what's going on? So once again, I go back to Homer. In one of his early papers, he was writing about the mechanisms for opinion formation, about the merits of a specific innovation. I need to be, and I'm sure we'll have some help, love to look at the opinion forming mechanisms about the applicability of biophysical system dynamics applications in practice, education, and research. Finally, the evolving science of healthcare delivery. Yeah, that is a transformation that is going on. It is the buzzword across the country. But I think in the absence of having the kind of profound operational insight, operational clinical insight that we can provide, diffusions are not going to rapidly go through them and enjoy widespread use. Okay, well, thank you so much for letting me walk through all of these things. I hope people are still there. But these are things I'm working on. I'm wondering what I'm missing, what I have wrong, what I need to adjust, what I need to study further. And so that takes me almost to the end here, to next steps. I would really like to benefit from your feedback. I will create, and working with Rafat and Seth, I will create something I can distribute to you that can facilitate some feedback from you. What do you call the instrument, Seth?
So we'll send out a Google form.
Thanks. Okay, we'll design that and figure out a way to get some open-ended stuff in there as well, and process that, and then distribute that early next week sometime. Put a 10-day window on it, and then I'll kind of compile and we'll figure out how to get back to you. And I sure would appreciate your comments and suggestions. So I'll continue to revise on the benefit of that, based on the benefit of that feedback, this material for the use at the conference in July in the Netherlands to work with biophysical group. I think I'll stop in and see the BSIG group. I'll come in and see you folks. And then what my burning desire right now is this third bullet. I really want to respond to folks that are saying we urgently need a clinical trial to understand this because it's affecting patients. And I will share this. I did contact well, I'll say it this way. We urgently need it, but that means someone has to do it. And I'm looking for who and how do we do this, and how do we inject a methodology like the ones we know and love into this, because we know it will provide an amazing response. That third bullet is really there. I'll improve my literature review, how that is working, and begin to clean this up and work with my own knowledge management processes on what we're talking about here, early on my own learning curve. And I think finally, I think there's a model we can develop to design the business strategies of navigating the expansion path that I alluded to with Abernathy and Clark, for example. Once again, we have an emergent technology, a new way of thinking about things. That's an old way, really, but it's new in these applications. We have possibly and it's disruptive, the technology we're talking about. Not because we're bad guys, but because it's changing the way things we're thinking about. And the markets for that are nascent. They're not people banging the door down and say, hey, give me the system dynamics clinical research bench. It's not there. All right. We need to create that, and we need to motivate that and move down the pathway to where they are there, and they are expecting kinds of models like that. And educational materials do include biophysical system dynamics models and so on, and that's there. So we can develop a model to look at the pathway from this emergent disruptive situation to a self-reinforcing thing, to understand what some of the limits to that market expansion might be, and identify on the fly policies for further transformation, and to figure out, how to jump to the next S-curve, if you will. Those are some of my next steps. And I believe that is all I have to say about that. And I want to thank you for listening, for letting me share this. I want to thank you for your questions and questions to come. And Seth and Rafat, I thank you for the opportunity to share this information.
Well, thank you for taking the time, Jim. We do have a question in from Bruce Scarin here. What about formal institutions that promote standards, regulations, and approaches, e.g., the NIH, the AMA, etc.? Are interactions taking place?
We are working with those. The Institute for Healthcare Improvement is continuously looking at ways to prevent the kinds of problems and underperformance issues that are involved with healthcare, notably the quality chasm from 2000 that said, hey, we're killing 100,000 people a year in our hospitals. Okay, but I know this is going to sound horribly arrogant. I think we've got a mindset thing here. We've got to sell an approach and a way of looking at the world that is hard to get across. And folks I know have approached Medicare or CMS, the central CMS, I'm going to call it, Medicare, with saying, hey, this is a way of looking at the world that could greatly improve patient outcomes and cost of delivery. And the CMS response is partly, well, we don't really mandate how people should go about delivering care. We just state what we will approve and what we won't approve. So, there's some interesting politics there. But fundamentally, it's a mindset issue to get sponsors and champions, advocates within those groups to respond and resonate with the suggestions we might have about how to do these things. I hope that makes sense, but they're there, and they're all aligned with the way the world currently operates, which kind of makes sense.
Well, that sounds like we have a fair amount of momentum to overcome, and this is the way it's done, and this is the way we've done it, and those changes are difficult to propagate.
I think we have to do one great example at a time.
Yes.
For a while.
All right. The lines are open, as they say, and feel free to leave comments in the YouTube comments field if you're having trouble with the Google Hangout. Otherwise, the Hangout comes directly to us. And we'll leave it open for a couple more minutes here. Jim, if you're done with the presentation, if you want to flip back over to video.
Oh, sure. Newbie here.
Yeah.
Right?
There we go. Let's see. We're still seeing myself and myself. So if you want to turn off your screen sharing.
Oh, thanks, bud. There we go.
Hello. Very good. Next comment we have from Julius. Statistics has two paradigms, frequentist and Bayesian. Trend is that Bayesian paradigm is gaining traction in a statistical world. Bayesian philosophy, in my view, is more compatible with SDST thinking. Bayesian clinical designs could help. What are your thoughts on the matter there?
For the little I know about that, I agree, and I'm picking up that trend. It was pretty well versed statistician who let me know about the ASA announcement, and he too was saying, you know, we're moving towards Bayesian. I need to understand that more. I've got a math background and I saw it during my studies and things, but I don't have a good enough understanding of it yet. I'd welcome more comments on that and suggestions on where to study and where to look at that. That sounds very helpful.
Thank you for the question, Julius. We've got a couple minutes left in the hour, so we'll probably leave it open for another 3 minutes or so, then wrap it up. While we're waiting here, Jim, have you thought about modeling the state of the transition, the actors involved, the mental models at play, and looking for leverage points there as kind of a meta model to applying a methodology in this instance?
Yeah, and that intersects very well with the health policy SIG, special interest group. We need to have conversations about precisely that. We didn't have time during this hour to talk about the states of Abernethy and Clark on how you go from disruptive, think of it, it's a 2x2 map. You've got disruptive and reinforcing technologies and markets. Well, the pathway through those can be mapped out, and I think that could be a very sound basis for a model to talk about what stocks are accruing when and how do we navigate those. I will be talking with the Health Policy SIG about that. To develop this material, Jack Homer was kind enough to spend a couple hours with me and talk it through. So I think that's very much in order to do something like that.
Yeah, there's some interesting work that we've done in our practice on diffusion of technological innovations and how consumers will decide to purchase one product or another that they may be applicable in this case, because we all work with simplifying assumptions, and those mental models are difficult to overcome, especially in the realm of uncertainty. And helping people understand and helping us understand and think through the mechanics of those decision makers might lead to some insights that'll give you better leverage.
I agree. Yep.
All right, we have one more question just popped in. All right, question about your modeling approach and feedback from your stakeholders. Have you worked mainly with classical systems dynamics modeling or also with agent-based modeling? And then second question, based on your experience, what is a stakeholder perception of different methods?
Well, let's take the first one first. Yeah, I had a chance to attend with Nate Osgood's boot camp, agent-based modeling boot camp with Jeff McDowell from Sydney, and we actually did develop an agent-based model centered on the question of the adoption of the anemia management protocol. So the players in the agent-based model were the physicians and the patients, and they would move through various states based upon, and the state of the patient was determined by the protocol that was applied, and the protocol that was applied was based on the state of the care provider. Okay, so there are definitely some agent-based applications here, and I really like the idea looking at things like AnyLogic, for example, of combining the modeling methodologies, because yeah, when it comes down to it, we're talking about the individual biophysical systems. We're also talking about individual decisions to adopt or not adopt. So yeah, I think there's real promise there, and we had a simple little model up and running to explore some of those things.
Mm-hmm. And the second half of the question, the expertise, the experience that, based on your experience, what is the stakeholder perception of the different methods?
Based on my experience, my data point of 1.
Fair enough.
The stakeholders look at this methodology and they recognize it as, frankly, mind-blowing. Here, I'll give you some specifics. I had one comment back to me after explaining to a nephrologist how this would work in terms of the application that nephrologists were looking at, and a different one. His response was, wow, if we take this on, we'd be in real danger of learning something. Right?
Okay.
And I laughed like you're laughing, but a year later I realized, wow, he may have been serious.
Mm-hmm.
He may have been, I don't want to rewrite my papers. Okay, I don't know. Real danger of learning something. other stakeholders have said. I have seen, and this is why I'm interested in following this. I mean, real physical people. One, this is, what was the comment? The quote was, "This approach could revolutionize medicine," quote unquote. Or McCarthy, if you look at his video, he'll say, "What I have to share with you today about hemodialysis is interesting, but this approach applies to all of medicine," unquote. And then finally, a hematologist was saying, after we reviewed the project with him and told him the kinds of questions we wanted to have answered, his response was, "Wow, this is exactly what should be taught in medical schools," and it is not. And that was, the hematologist said, because docs are being taught to prescribe, not to understand. Okay, so to the ones we can reach, they're saying, "My gosh, there's really something here," and it's big. It's big. So we have to make it maybe less, I don't know, overwhelming.
Yeah.
I don't know, but that's the response I've gotten.
Yes, because the broad applicability, although it is an asset for those who understand how to apply it appropriately, it can also be a detriment for those who are skeptical, as the case may be.
Yep.
So we are at the top of the hour here. Thank you very much, Jim, for taking the time to present. We really do appreciate it. If you joined the presentation late or want to review it and share it with others, today's episode is available now on the BSIG YouTube channel. Many of you are watching that. Feel free to share those links. Jim, again, as he mentioned, is looking for feedback on the work, and he will be sharing a short form early next week. We'll get that shipped out to you. If you're interested in joining the BSIG mailing list, please do let us know, either in comments or yeah, in comments is probably the best way to do it. Thank you, Rafat. Actually, if you want to come off mute, Rafat, you deserve a fair amount of thanks here for your efforts for putting this program together. Really do appreciate the suggestion. We've got a lot of good results back from our first webinar, and we expect the same from this one. The more we can push this out there and get this in front of people, in front of prospective problem owners, the better we'll do in sharing these insights and innovations. So today, Rafat, to thank you again for your contribution. He's been managing the various comment channels and making sure those get funneled through so that your opinions, your questions are reaching our ears and we can answer them live here on the air. If you're interested in sharing your work or know of someone who may want to present, please do let us know. We are booking a couple months into the future, so stay tuned to the Google group, and we'll announce our next webinar soon. In BSIG news, as I mentioned last time, we've launched stories.systemsdynamics.org. It is a recurring series of articles highlighting select cases for problem owners and those interested in how systems dynamics and system thinking is being applied. We have an article featuring Jim's work with the Mayo Clinic, and we encourage you to take a look and share these articles with others. If you're interested in learning more about the initiatives of the Business SIG, you can read more at sigs.systemdynamics.org/business. And thank you again, Jim, for taking the time, and thank you to our loyal watchers, listeners, and we'll see you again next time.
Thanks, Seth.